Now, this is similar to the previous problems that we've worked that had rational expressions in them. And we had to multiply through by a common denominator to get rid of fractions. If we just have rational expressions and we have a choice, at some point when you're working with rational equations, and this is a true rational equation, it's not just an equation that has rational expressions in it, it's a true rational equation because it has a variable in the denominator. If an equation has a variable in the denominator, then we're talking about not just an equation that has rational numbers in it, but we're talking about an equation that is a rational equation. And there's some interesting things about rational equations. They're excluded values that we have to be careful of because you can't have a zero in the denominator. So no solution that we came up with that would give us a zero in the denominator can stand. We're going to have to reject some answers in this lesson. And we're also going to deal with the fact that we can multiply an equation by anything except 0. It's not allowed to multiply through an equation by 0. So whatever we're multiplying by can't be 0. And that's going to be one of the places where we get our excluded values from. That's really good enough to just consider that. Okay? Now, common denominator here. If we were having to add these expressions, what would our common denominator be? 4x, right? You could use 8x. Bryce, your instinct for 8x would work. It's just going to give you something to simplify a little bit later. 4x is going to be the smallest one that'll work. So what I want to do is multiply each of these terms, multiply through the equation by 4x. Let me get that one a little clearer here. 4x. And 4x. So we're legal here. What we've done is legal as long as we're not multiplying by 0, which means x cannot equal 0 in this problem. But we know that already because this x in the denominator right here can't be 0. So x can't be 0 is our excluded value for this problem. All right, when we multiply by x, 4x rather, this x will cancel when we multiply that term, and 4 times 1 is 4. When we multiply the next term, the 4's cancel, and 3 times x is 3x, right? And when we multiply the next term, 2 goes into 4 twice, and we're left with 1 times x times 2, which is 2x. Now it's a pretty simple problem to work, isn't it? We can subtract 3x from both sides. And that's going to give us 4 equals negative 1x, or negative x. Swap both signs, we get negative 4 equals x. That's a good answer. Why do we know that's a good answer? With rational equations, we have to make sure that our answers are good. How do we know this is a good answer? Because it's not 0. All right, it doesn't make any of our denominators equal to 0. We're just going to do a couple more examples, so y'all hang with me. I know it's Wednesday. When the going gets tough, Miller goes to sleep, right? Y'all ready? Next example. Here we go. 3 over x plus 2 equals 5 over x plus 2. What do we need to do here? What's the problem? We've got to get rid of the fraction so we can get x isolated. We've got to get x out of there. So what am I going to multiply by? X plus 2, right? Multiply this one by x plus 2. Multiply this second term, don't forget the 2. We're going to multiply it by x plus 2. And we're going to multiply this one by x plus 2. Multiply through by x plus 2. Some of you can do this. I mean, these are easier problems. You can do these just about without showing the work. But what's important at this point is that we make our disclaimer. We cannot multiply by 0. So x plus 2 cannot be 0, which means x cannot be negative 2. There's our excluded value. Can't forget that. Can't forget this exclusion. Okay? Then we'll do what? X plus 2's cancel here, leaving us with 3. 2 times x plus 2 is 2x plus 4. 5 times x plus 2, the x plus 2's cancel, and we're just left with 5. Right? Combine the 3 and the 4, we get 2x plus 7 equals 5. Subtract 7, we get negative 2. Divide by 2, we get x equals negative 1. How do I know that's a good answer? Because it's not equal to negative 2. Right. That's the only thing that excluded value is there for. To remind us that if we get negative 2 as an answer, we have to reject it. All right. And there will be at least 1 or 2 on the test that have excluded values where we have to kick the answer out. And if we get that answer, then we would have to say that there's no solutions. All right, let's work one more. Can y'all do one more? Just one more? Just one more? Just one more. Noah, what do we need to multiply everything by to get rid of all of our denominators?
2 times x minus 3.
2 and x minus 3 is correct. So we'll need a 2 and an x minus 3 on this term. I need a 2 and an x minus 3 on this term. And I need a 2 and an x minus 3 on this term. And because I'm multiplying by x minus 3, I'm not allowed to multiply by 0, which means x is not allowed to be what? Positive 3. That's important. I'm not going to ask you to provide that because as long as x is not equal to positive 3 when we solve this equation, that information is not all that interesting for us. When we multiply the first term, the x minus 3's cancel. 2 times 4 is 8. When we multiply the 1/2 by 2 times x minus 3, the 2's cancel. And 1 times x minus 3 is just x minus 3. Right? When we multiply the next term, the x minus 3's cancel. We're left with 2 times 2, which is 4. So here we have x plus 5 equals 4. Subtract 5 from both sides, and x equals negative 1. And that's a great answer because it's not equal to 3. All right? Okay, we'll pick up here tomorrow and finish